Hello again, everybody. It's Pete from Hacking Math. Just wanted to put out a video for today's LeetCode problem called perfect squares. Let's see, given an integer, return the least number of perfect square numbers that sum up to that number. Like if it's 12, then you have to give 3 is the output because these 3 square numbers add up to 12. That's the lowest number. I knew there had to be a recursive solution, but once I started to whiteboard it, I got a much easier way. So for 12, all we're looking at is the square numbers smaller than 12. So we don't need them all the way up to 10,000, which it said the number could be. And then each time, like we don't have to say which ways it's doing it. We don't have to say 4 plus 4 plus 4. We just have to say 3. So if we go through and just add every square number, not add, subtract every square number from 12, right? We get 3, we get 8, and we get 11. That should have been faster. So that's after one turn. So, I don't know, turns equals 1. If you get 0, then you know you can just return that number. So we don't have 0 yet. So for each of these, we just have to subtract the square numbers that are smaller. So for 3, there's only 1. That gives us 2. For 8, you can subtract 4. You can subtract 1. That gives you 4. And 8 minus 1 is 7. 11, we can subtract all 3. We can subtract 9, we can subtract 4 and 1. We get 2, we get 7, and we get 10. All right. Now we're subtracting. This is for turn number 2. This is going to be turn number 3. And here, if you subtract 1, you're left with 1. But here, you subtract 4, and you're left with 0. So we don't have to keep going. We know that in 3 turns, no less than 3 turns, we can add up to 12. So how am I going to do that? I'll need a list of the square numbers less than n. And then we don't even need, like you see, you've got a couple of 2's there. And I use a different color. We've got a couple of 2's here. You really wouldn't have to do that twice, right? So there's something in Python called a set. So if a list has 2, 4, 7, 2, 7, and 10, the set version of that, if we make it into a set, that's going to look like this. Only need to express the numbers once. So I'll make a set. Let's see, list of squares, square numbers, less than or equal to n. I guess if if we subtract once, it just takes 1, right? Then a set of the differences, n minus each number. Keep track of turns, and then we keep adding to turns each time. All right, let's see how that's going to look. First, we make our squares list, our list of square numbers less than n. Here's how I did it. It's a list comprehension. It's just going to give you all the square numbers up to and including n. Then we're going to set the turn equal to 1. And then just put diffs. For differences, that's going to be n minus s for s in squares. Right? 12 minus 9, 12 minus 4, 12 minus 1. That'll keep that differences. Now, while 0 is not, don't have to say is, not in diffs, we're going to make turn go up by 1. If it is in diffs, then it's not going to do all of this. The output is just going to be 1. Let's see, we'll make the turn go up. Now this is turn number 2. We're going to make a square set. Then loop over the squares for s in squares. Then for every number in the diffs list, we're going to say if the difference between D and S, like now we're going to subtract square numbers from the differences again. If that number is greater than or equal to 0, then we're going to add it to the square set. Then we'll just make, we're looking for diffs, so we'll make diffs equal to the square set. Okay, if there's 0 in the diffs set now, then it's going to skip that whole loop and return the turn. Yeah, not turns, turn. Okay. And that should run fine, so 81 milliseconds, and if we submit it, then we get, it beats 86% of users with Python 3. Does it in 474 milliseconds. Not bad. So, if you enjoyed this, like and subscribe, and I'll see you in the next video. Bye.